All right, so let's look at then a couple, since you don't have any other questions. Let's look at a third degree where you're going to have to do the quadratic formula, something where I already know once you get down to that second step, there's no possible way for you to factor it. Right? So this is our next example. Let's call it example B. And so here's our function, our equation we're working with is x cubed plus a 7x squared plus 11x minus 3. And I'm only going to give you one of the factors. So since this is a third degree, I only need to give you one factor for you to be able to get the result, a quadratic that could be factored or some formula. All right. So again, our goal is that we need to be able to factor this completely, and we need to be able to find all of our zeros. And so the first zero is going to be negative 3. And I know one of my factors is x plus 3. So my goal now is to find the other two factors and the other two zeros. All right, so third degree polynomial, all of the powers are listed. So use your negative 3 on the outside and just start writing coefficients. Again, make sure that you have the right sign. I have a bad habit of writing a negative instead of a positive, or vice versa. So drop down your 1. And now start your synthetic. So you can see, like, part of the reason why we spend so much time on synthetic is this is going to be way easier than doing long division over and over and over and over again. So negative 3 times 4 is a negative 12. And I should get a positive 3, so I have no remainder. So again, what you have left is now you have a quadratic left. And I can tell that this is not going to be factorable. If I just look at the first, the a and the c value, I get negative 1. There's no way I can take factors of negative 1 and add up to be 4. Right? So my second step is now I have to use the quadratic formula. So I'm going to use the quadratic formula to solve. So what I'm doing is when I'm solving, I'm actually not finding the factors. I'm actually finding the zeros that I will turn into factors. So I'm kind of going backwards. Whereas when I give you a factor, we can set it equal to 0 to solve for one of the zeros. Now I'm going to be getting a 0, and my final step will actually be going backwards to find the factor so that I can rewrite this. So I'm going to use x equals, and if you have to go off to the side again, the a value is 1, b is 4, and c is negative 1 for this particular problem. So again, the opposite of b plus or minus b squared minus 4ac all over 2 times a. So underneath the radical is going to be the square root of 20. And so this is a positive root, or it's a positive radicand, which means we're not going to have an I. All right? When you see the square root of 20, we just need to break down the perfect square and the non-perfect square inside the radical. So right now I've got negative 4 plus or minus. The square root of 4 is 2 with the root 5 still left underneath over 2. And you have to simplify this down. All right, you can't leave it that way because I have to write this as 2 separate zeros. So I can take a factor of 2 out of everything. And so my x values are either -2 plus root 5 and -2 minus root 5. Those are my other two zeros. All right, so when we're using the quadratic formula to solve, we're solving for the zeros, not the factors. As long as you have the factors, you can find zeros. As long as you have zeros, you can find factors. They go back and forth. So these are my other two. I'm going to kind of put them over here on my list. So I have one of the zeros is at -3. Another one is -2 plus a root 5. And -2 minus a root 5. And what that means is that it's some sort of decimal. I don't know exactly where it's at when it touches the axis, but it's not going to be a nice, pretty little dot I can plot. It's going to be somewhere in a decimal range. Right? So here's your zeros. Right? But now to find the factors, you kind of have to think backwards. So when we have x plus 3, and we set it equal to 0, so that way you can find a number to use for synthetic division. Now you need to move everything over to one side instead. So to find your factor, you're going to have to move this -2 to the other side of the equal sign. And you're going to have to move the plus root 5 to the other side of the equal sign. And when you do that, it changes their signs. So x plus 2 and minus root 5 are on one side of the equal sign if I try to set this equal to 0. If I put parentheses around this, that's my other factor. So just like it was up here when it was x plus 3, and when I set it equal to 0, I moved that 3 over, and on the other side of the equal sign it became negative. Now when I move everything over to the other side, it puts a factor. And it looks kind of funky because of the way that the quadratic formula is, but that's your factor. Same thing here. You got to move the negative root 5 and the -2 to the same side as the x. You're kind of doing the opposite of what you think you would do. And so then that means you have an x plus 2 plus a root 5 on the same side. And that's your other zero. And so I don't have much space up here, so I'm actually going to forget about this for a second. And I'm going to rewrite my function. I still have that x plus 3. But now the other two factors are the ones that I created from the zeros. And what you want to be able to notice is that it looks kind of weird, obviously, because you put everything on the same side. But if I were to take this factor and set it equal to 0 and isolate the x, I would get back up to what it looked like when I solved for my zeros. So when you are using the quadratic formula and doing synthetic division, it's a little bit different steps. Your first step is still going to be to use the synthetic division, but then your second step is going to be finding the zeros and then creating the factors from there versus factoring and finding zeros like we did in the other steps. So we've got a couple that we're going to do, right? Because that's a lot. There's a lot going on there. All right, so let's do another cubic. So let's not make it any more difficult yet. Let's go with another cubic. Sometimes once you get more than one example down, it starts kind of coming together, making sense. So we're going to work with the polynomial. We've got x cubed plus 4x squared minus 20x minus 80. And I'm going to give you x plus 4 as the factor. So depending on how you want to write it, if you want to, you can always just start making your list first, saying I know I'm going to need to have a factor of x plus 4, and then I need to find my other factors. And you can make a list of your zeros at the same time. And that way I don't have to rewrite like I did last time. So I'll do all my work underneath it so that way I can put all of my final answers up here when I'm done. And give myself just like a little fill in the blank space. since that's my ultimate goal, is to get those two answers. So again, you have a cubic or a third degree, and since I'm giving you one of the factors, we can do our synthetic. Almost all of the polynomials I'm going to give you right now are all going to be including all of the terms. So you're not really going to have any placeholders right now at all. It'd be too hard to start adding that in. All right, so drop your 1 down. And so it's okay that I get zeros as I'm starting to do my work. Just keep going with the process and making sure that you add vertically. Because the last step, the -4 times -20, is a +80. And that's what I want anyway, so it's okay that there's alternating zeros in here. What that means is that, bless you, is that if this is the coefficient on the x squared, the x, and the constant, that really what I have left is I have a polynomial that's just x squared minus 20. I don't have an x term, and I actually kind of like these. All right, what this is going to do is we don't have to use the quadratic formula for this. All right, if I still do my second step of solving and I set this equal to 0, I can use an old property from Math 2 where I can move just the 20 over to the other side and take the square root of both. The only thing you have to remember, though, is that you need the plus and minus attached to that radical. So the values for x are going to be plus or minus what happens when I break up that square root of 20. So the square root of 4 is 2 with a root 5. So it's not going to look the same as a quadratic because there's no b value. So if you're going to set up the quadratic formula, you're going to get a 0 plus or minus some stuff. So there's no number in front of here like there was on the previous step. And so you've got 2 zeros. All right. Actually, I'll put them up here. You've got 2 zeros, either the positive 2 root 5 or the negative 2 root 5. So if you think about your zeros as being still on opposite sides of the x, when you move them over, you're still just adding or subtracting to move them over to the same side of the x. So that means my factor is going to be an x minus 2 root 5, and the other factor is going to be an x plus a 2 root 5. And then I'll put those back up here. So sometimes when you are solving, you are going to be either factoring using area boxes or any other guess and check type work. All right, you are going to either be then using the quadratic formula if it's not factorable. And if you get something like this where you get no b term, instead of using the quadratic formula, it's going to be easier, or it could be easier, to just use what we call the square root property, where we can just take the square root of both sides to solve. And it leaves us a little bit less work than doing the quadratic formula, but you're more than welcome to do the quadratic formula if you like.